Well done to all of you who've completed the 2021 higher level paper 2 maths pre-exam from the tuition center. We're going to go through the 10 questions here and their solutions and the marks given to each of the questions. Let's start off here with question 1, a 30-mark question, as all of the 6 short questions are this year. When the students flicked over the page, they'd see this trigonometry question. The angle of a sector in a circle of radius 8 centimeters is pi. I'm just moving something here on my screen. Let's move there. It's moved for me now. Is pi over 7 radians as shown in the diagram. By finding the length of the arc, find the exact value of the perimeter of the sector. So some people, when they see this, they'll just move on. They'll see radians, they'll see, arc lengths, and they'll just kind of know this is a section that they haven't studied that much. But for others, they'll be looking at it and saying, yeah, this is straightforward. They'll know the formula for the arc length is in the table books, and they might know that it's r times theta, the angle, where theta is in radians. And in this case, it's pi over 7. So when I multiply that through, it's 8 pi over 7. That's my arc length. And it would be centimeters. But because I'm asked for the perimeter, I'll just calculate my perimeter first. So it's 16 plus 8 pi over 7 centimeters. And that's correct because it is the exact value that we were looking for. So that was 5 marks. Not too difficult once you get into it. Here we have a 2D diagram. It says the right angle triangle, ABC, has a hypotenuse, AB of 13. So here's my 13. The point D is on AC such that DC is 4. We have the angle DCB is pi over 6. The angle ABD is X. We start off by looking for BC, which we have down here. BC is equal to 4 root 3. That's what we're asked to show. Well, we're looking at the various different triangles we have there. In a question like this, I'd say to students in the exam, often it's best to redraw the individual triangle that you're going to use. In this case, because I can highlight it here, I just highlighted it. For a student, I would probably still advise to just draw it out individually, because sometimes things become obvious once they've been drawn out as an individual triangle that sometimes they're not so obvious when you see the full diagram together. So in this case, we're going to be using 4, which is my opposite. This length is what we're looking for, BC, that is my adjacent. Tan uses the opposite and the adjacent, so I'm going to say the tan of the angle. So tan of pi over 6 is 4 over BC. You got to be careful, make sure your calculator is in radians. When you get the tan of pi over 6, you're going to get 1 over root 3, or possibly more likely, you might get root 3 over 3 from your calculator. And then I'm going to isolate BC, so I'm going to multiply across by the, I'm going to multiply both sides. I was going to say cross multiply, but just in case you don't like that term, I can multiply both sides by root 3 times the length of BC, or root 3 times the length of BC. Obviously, those will cancel down on the right-hand side, the root 3s will cancel down on the left-hand side, and you're left with BC is equal to 4 root 3. So that was 10 marks. And again, once you're comfortable with this stuff, it was an easy 10 marks. But we know some people will be thrown off by the idea of using the radians. They might just not be as comfortable with it. Hence or otherwise, find the exact value of the sine of x. So this is one students might have to think about for a while. How am I going to find the sine of x? And often you're asked to find x itself, but in this case, it's actually the sine of x. So you might be thinking, right, a right angle triangle, but x is not contained within a right angle triangle. If your x was in a right angle triangle, you might be thinking, opposite over hypotenuse. But anyway, sometimes you just got to start. You got to see what you can do. So sometimes it's a case of just trying to work out, well, x is in this triangle. I have only 2 bits of information, so I can't really do much yet. So let's see what else I can find out. Well, I can figure out this guy up here. If I call it y for now, I can figure that out because I now have the 4 root 3 and I have the 13 within the right angle triangle. And that can allow me so to figure out the length AC. So in this right angle triangle, I can use Pythagoras' theorem. And in this, I can say AC squared plus 4 root 3 squared must be equal to hypotenuse squared, that's 13 squared. And with a bit of work there, I can figure out that AC is going to be equal to 11. And therefore, I can figure out that AD is going to be equal to 7. So this length here is 7. I now have 3 bits of information for this triangle, well, one of which is that this is the angle X. I still need one more bit of information to form, an equation that will either use sine rule or cosine rule. So I'm searching for one more piece of information here. And what I can do is I can find this angle. So how can I find it? Well, I can say the angle ADB is equal to pi over 6 plus pi over 2. Now, where's the pi over 2 coming from? It's coming from here. And what is this? Well, this is a little bit of geometry knowledge, that the exterior angle of the triangle is equal to the sum of the interior opposite angles. So in this case, this angle here in green is equal to pi over 6 plus pi over 2. What's that going to be equal to? 2 pi over 3. 2 pi over 3. And what am I going to do then with my 2 pi over 3? I now have 3 bits of information. It's a non-right angle triangle. In this case, I'm going to use sine rule. Why? Because I'm looking for this angle here, X. I have the side opposite it. I have another angle and the side opposite it, so I can use the sine rule. So in this case, you could use it like this: A over sine A is equal to B over sine B. But as I always say, whatever you're looking to isolate, it's easiest if you keep that up on the top left-hand side. So in this case, I'm going to use the sine of X over 7 is equal to the sine of 2 pi over 3 over 13. Having it written this way with the angle on top saves you one line of work. So in this case, I'm going to multiply across by 7. I can type all that into the calculator, and that's my answer. The sine of X is equal to 7 root 3 over 26. And again, it's the exact answer. And that was 5 marks. The next part of this question is separate from the other parts. And as we often say, it's something you just have to keep an eye out for. That in this case, that I'm just going to move this here so I can hit on something. So, you might have been struggling there towards the end of that last question, if maybe, particularly if you made a mistake anywhere. But this part is completely separate. So you kind of start again. You say, all right, find all the solutions to this equation. So X is the variable. So what are you going to do? You're going to try and isolate X. How are we going to do it? Well, I can say, okay, I've got sine squared and I got cos. I know from my trigonometric identities that sine squared A plus cos squared A is equal to 1. So sine squared A is equal to 1 minus cos squared A. So in our case here, I'd say sine squared X is 1 minus cos squared X. I multiply through, tidy up. The 2's will actually cancel out. And now I can say the following. I can say 2 times cos squared X plus cos X equals 0. And you can imagine if you'd minus, so it's minus, I don't know, did I say the minus, but minus 2y squared plus y equals 0. And if that's what you had, you could factorize out the y, and you'd have minus 2y plus 1 inside your bracket. So actually what's happened here is I've factored out here, and I've also rearranged at the same time. So if I did the factoring first here, I'd be factoring out my cos of X, and inside the bracket I have minus 2 cos X plus 1. And I know that's correct because if I multiply back through, so if I multiply back through this bracket, I would get back to where I started with. So it's just slightly rearranged here now in this line. I have my cos X times 1 minus 2 cos X. And that still equals 0. If I have two things multiplied together equals 0, well, either the first is 0 or the second is 0. If the cos of X is equal to 0, well, then I'm going to have 2 answers, right? And if the cos of X is equal to half, I'm going to have 2 more answers. I know here because it says 0 is less than or equal to x is less than or equal to 2 pi, I am going to be dealing with radians. I'll just draw my unit circle here for a moment. 0, 90, which is your pi over 2, your pi, your 3 pi over 2. So those are your radians, your angle of rotation from the origin. I know that this point here is 1, 0. I know that this guy is 0, 1, minus 1, 0, 0, minus 1. And in this case, I'm looking for two values where the cos of x is equal to 0. So where is cos equal to 0? Well, cos is equal to 0 in two places. Let me do this here. I'm just going to change my highlighter. Cos is equal to 0 at pi over 2, and cos is equal to 0 at 3 pi over 2. So those are two places where having pi over 2 or 3 pi over 2 for x will get you cos of that equal to 0. For cos x equals a half, some of you will be thinking of cast here. So, or possibly also terribly confusing. All students take calculus, something like that. And what do we do? In this case, if we get the inverse cos of a half, we get a reference angle of pi over 3, 60 degrees. In these two quadrants, cos is positive. So if I make my reference angle of pi over 3 with the horizontal in both cases, well, that degree of rotation is just pi over 3. So that's one of my answers. And how far do I have to go to the other blue line? Well, the full rotation would be 2 pi. And if I subtract pi over 3 from 2 pi, I'm going to get 5 pi over 3. Those are my 4 different solutions. They're all within the domain, so they're all valid solutions. And that was 10 marks. As I said, you could get those 10 marks without ever getting any of the earlier marks. So it's just worth remembering that when you're doing the questions. Okay, that's question 1 done. Let's go on to question 2.